So you've got a motor spinning at 5,000 RPM, but you need 250 at the output shaft. What gear ratio gets you there, and how much torque will you actually end up with after efficiency losses? That's exactly the kind of problem this gear ratio calculator solves in about 10 seconds. It works across 4 different modes. You can calculate your gear ratio from tooth counts if you know the physical gear sizes. You can calculate it from measured input and output RPMs if you're working with an existing system. Or if you already know your ratio, you can flip it around to find your output speed or output torque, including a gearbox efficiency factor, so your numbers actually reflect reality instead of textbook ideals. The core formula is straightforward. Gear ratio equals driven teeth divided by driver teeth. A small 20-tooth driver meshing with a 60-tooth driven gear gives you a 3-to-1 ratio. That means 3 input rotations for every 1 output rotation. Speed drops by a factor of 3, torque multiplies by a factor of 3. The trade-off is always proportional. Double the torque, half the speed. But real gearboxes have friction losses. So the calculator lets you set efficiency anywhere from 85% for multi-stage systems up to 99% for precision single-stage helical gears. Where does this matter in practice? If you're sizing a gearbox for a conveyor drive, you need to know whether your motor and reducer combination actually delivers enough torque at the belt speed you require. If you're building a robotics arm, getting the ratio wrong means your joint either moves too fast, with no holding strength, or crawls with wasted motor capacity. And if you're designing a custom gearbox for a go-kart or an electric vehicle project, this calculator lets you test different tooth count combinations before you commit to machining anything. Find the link in the description below to use this calculator and read the full engineering guide.